Let's have a look at this exercise on confidence interval on the difference between two means. So tensile strength tests were performed on two different grades of aluminum spars. Okay, two different grades of aluminum spars used in manufacturing the wing of a commercial transport aircraft. From past experience with the spar manufacturing process and the testing procedure, the standard deviation, okay, here the standard deviation of tensile strengths are assumed to be known. Okay, in this case, we assume we know that sigma 1 and sigma 2, we assume they are known. Okay, the data are as follows. So the sample size and 1, so two different grades. For the grade 1, we have 10 specimen, and sample 2, we have 12. Then we got the sample mean, and this population standard deviation are assumed to be known. So if mu1, mu2 denotes the true mean tensile strength for the two grades of spars, find the 90% confidence interval on the difference in mean strength. So in this case, we have two population, two grades, two different grades of aluminum spars. And we know the population has mu1 and sigma 1 and mu2, sigma 2. And then we got a sample 1 and sample 2. In sample 1, we got x1 bar and s1, the standard deviation. And this is the sample mean for the second sample. And we also got a standard deviation. You can compute the sample mean and the sample variance or sample standard deviation. Now the question is to derive confidence interval on the difference here between two population means. Okay, so this will be 90%. So here, this is 100, 1 minus alpha percent. That is, will be 90%. And because this is 90%, so alpha will equals to 0.1. And alpha over 2 will equals to 0.05. So z alpha over 2 equals to z 0.05. So we have already derived this z 2.05. So if we look at the table, 0.05, 0.05 should be one, well, it's right here. So see here, 0.0495, 0.0505. So in the middle of these two, that is 1.645. So this will equals to 1.645. Based on the equation, mu1 minus mu2 and the population standard deviation and variance are known, so this will equals to less than x1 bar minus x2 bar. Okay, so plus z alpha over 2, we have sigma 1 square over n1 plus sigma 2 square over n2. This will be greater than x1 bar minus x2 bar minus z alpha over 2 square root sigma 1 square and 1 sigma 2 square and 2. We know the sample mean here, so 87.6 minus 74.5 plus 1.645. So this will be 1. So that's 1 square over n1. n1 is 10. So 1.5 square over 12. Okay. mu1 minus mu2 less than and then greater than. So this side, similarly, we just have a negative sign. So it is minus 74.5. So we got a negative sign here, 1.645. Still, we got 1 square over 10 plus 1.5 square over 12. So in this way, we will get 90% confidence interval as, let's do the computation here. So this side will equals to 13.98. So this is mu1 minus mu2 less than this number, and then greater than 12.22. So this will be the 90% confidence interval on the difference in mean strength mu1 minus mu2. So notice that this confidence interval, okay, this confidence interval is positive and does not include 0. So 0 is not in part of it, implying that the mean strength of alumina grade 1, that is mu1, exceeds the mean strength of alumina grade 2, mu2. In fact, we can state that we are 90% confident that the mean strength of alumina grade 1 exceeds that of alumina grade 2 by between 12.22 and 13.98 kilograms per square millimeters. So that's the conclusion, because 0, this interval does not include 0. So we can state that we are 90% confident that the mean strength of alumina grade 1 exceeds that of alumina grade 2 by between 12.22 to 13.98 in the significant level of 90%.